Hello everybody. Today we are going to do 9.5 and 9.6, reading and writing scientific notation. Please make sure you have your notebooks out, pencil, and I don't think you're going to need a calculator today. I think most of this is without a calculator. Remember to pause the video anytime you need to catch up or take notes. So let's start with a couple of questions. If you took a calculator and multiplied 2 billion by 3 billion, so here it is, 2 billion by 3 billion, and remember a billion is quite a few zeros. So there's 2 million, there's 2 billion, times 3 billion. If you tried putting this into your calculator, you would get a number that is basically too big to even fit on your calculator. If you want to do it sometimes, try it. It's going to give you weird notation because it's way too big. Same thing would happen if you tried to multiply 2 billionths times 3 billionths. And if you look right here on our little calculator head right here, there it is, 2 billionths times 3 billionths. And just like the previous page, only now this one is going to be too small for our calculator. So instead, we have a way to shorten really long, really big or really small numbers up. So when we talk about certain things, we use really big numbers. So for example, as the planets orbit the sun, the closest Pluto gets to Earth is approximately 2,700,000,000 miles. That's a really big number. And so instead of constantly writing those big numbers, astronomers shorten it up to what we call scientific notation. The same thing down here. We have scientists that use really small numbers. Human fingernails grow at a rate of about 0.00286 inches per day. So again, because it's really small, they shorten it up to scientific notation. So this should go into your notes. So pause the video and write it. Come back and we will go through it. Scientific notation. A number is written in scientific notation when it's represented as a product of a factor and a power of 10. The factor must be at least 1 and less than 10. So we need to make sure we have this. First of all, it's a product, so we're going to be multiplying. The factor, which is at least 1 and less than 10, is that first number. Then the power, it's a power of 10 that has an integer exponent. And we've been talking about exponents, so we know we can have negative exponents. We're going to leave negative exponents. We're not going to change them. But out of all of this, this is the part that you should definitely have in your notes. So let's see if you can at least tell. So this example says, tell whether the number is written in scientific notation and explain why. So let's go through these together. Letter A is definitely written in scientific notation. That first number is between 1 and 10, less than 10, times 10 to the power of negative 6. So we have the factor, that's between 1 and 10, and the power of 10. So letter B, no, this one is not. We have the multiplying by the power of 10, but our factor is less than 1, and it's got to be more than 1. 1 to less than 10, okay? That's what we're looking for, and that one is not. Letter C is also not. We have a factor that's between 1 and 10 times, but here we have a power of 5, not 10. It's always going to be times 10. So take a moment to look at these 9 examples and circle the ones or pick out the ones where you feel are in scientific notation. Come back when you are ready. So let's go through them. Factor between 1 and 10, power of 10 times power of 10. First one definitely is. Second one, not. We have a number that's greater than or less than 0, less than 1 because it's a negative. So that one is definitely not. Between 1 and 10 times the power of 10 works. Not between 1 and 10. Between 1 and 10, power of 10 definitely works. Not between 10, not between 10. 10, yep, and there we go. That one works. Not. This one is not. So there we go. We had 4 of them. The first one, the third one, the fifth one, and the 8th one. So let's start doing this. And this, I think, should go in your notes. So if you want to pause the video, write it down, and then come back, we're going to go over how to do this. So if we have a positive exponent, it means your number is really big. Don't worry about which way to move it. You can put it, the decimal is going to move to the right. That's fine. But I want it very big. So if you have it, a number between 1 and 10 times 10 to the power of 3, you're going to take this number, you're going to move the decimal once, twice, 3 times. We're going to put a 0 in that blank. So and put a comma where it needs to, 4,230. So that's a big number. This one, not so much. We're going to get bigger. Down on the bottom, a negative exponent means your number is really small. So again, we're going to start with our factor, and we're going to move our decimal. Now it's really small, so we're going to move it to the left 4 times. So here's our decimal, 1, 2, 3, 4. Here's where our decimal point goes. We fill in the zeros. So we have 0.12307003. You can't get rid of the rest of the problem. That's a really, really small number. So let's practice doing this. So let's start with a big number because we have a positive exponent. So I'm going to start with 7.9. I'm going to take my decimal and I'm going to move it 5 times. 1, 2, 3, 4, 5. I'm going to fill in 0, so I got 1, 2, 3, 4 zeros. So I have 7, 9, 1, 2, 3, 4. Put in my commas. There's my answer. Same way, negative exponent. So I'm going to kind of give myself some room back here, 3.22. I'm going to take my decimal. This is a small number. I'm going to go 4 to the other direction. 1, 2, 3, 4. Here's where my decimal is. I need to put in 3 zeros. So I got 0.12332. And there's my really small number. So positive exponents, big numbers. Negative exponents, small numbers. If you want to try doing these two on your own, pause the video and then come back. Otherwise, here we go. This is a negative exponent, so I'm going to start back here, 9.3. I'm going to go -6. So 1, 2, 3, 4, 5, 6. So there's my decimal. I'm going to add 5 zeros. So I'm going to rewrite it. 1, 2, 3, 4, 5, 9, 3. There's my answer. Now I have a positive exponent, so 6.3, and I'm going to go the other direction. 1, 2, 3, 4. I'm going to plug in 3 zeros. So I have 6, 3, 1, 2, 3. There's where my comma goes. There's my answer. Again, try these on your own. We're going to write them in standard form. Standard form is the way you are used to seeing them. These are in scientific notation. Standard form is the way we normally see numbers. So try them on your own, pause the video, and then come back. 6 with 7 zeros, because here's my decimal point. So 1, 2, 3, 4, 5, 6, 7. I'm going to put in my commas. I'm going to erase this decimal point so that I know it's not there, but there is my answer. 9.9, go backwards 5, 1, 2, 3, 4, 5, 1, 2, 3, 4 zeros. So point, 1, 2, 3, 4, 9, 9. Now this one is interesting. I got an exponent of 4, so I'm going to move it to the right 4 places. 1, 2, 3, 4. I'm only adding 1 0, but I can't take out the rest of those numbers. There it is. So find the density of the brick and the apple in standard form. So I got an exponent of 3, so I'm going to move it 1, 2, 3, which means I'm going to add a 0. 1,840. Not a huge number, but definitely bigger. Here we only have an exponent of 2, so it's only moving twice, so we're not adding any zeros. This would be 641. So the question down below says an object with a lesser density than water will float. Based on the density of the brick and the apple, which one would float? So our water has 1,000 kilograms. The apple is less, so the apple is the one that would float. So we're going to start with our second lesson today. We're starting writing scientific notation. So it's kind of the opposite. Before you were reading it, learning how to write it, learning how to do it, but now we're going to write scientific notation. So let's put this page in our notes. Writing scientific notation, step 1, you're going to move the decimal to the right of the first non-zero digit, count the number of places, determines the exponent, and again, positive exponent are really big numbers, negative exponent is really small numbers. So now I want to write it in scientific notation. So I'm going to use my number that's in the problem. Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. So I'm going to start with my numbers up here. I know my decimal point has to go right there. So my factor is 1.65 times 10. Now the only thing we need is the exponent. So here's where my decimal point is. 1, 2, 3, 4, 5, 6, 7, 8, 9 is where it ends up. So my exponent is 9. We can use another really big number. Here's where I want my decimal point, but here's where it is in that factor. So my factor is 2.45 times 10 to the power of 1, 2, 3, 4, 5, 6 is where it ends up. So I have a 6 as my exponent. Now let's go the other way. Now we have a really small number. In 2004, Indonesian earthquake slowed the rotation of the earth, making the length of the day 0.0000268 seconds shorter. Barely anything at all, but we still need to do it. I want my decimal point to go right here because my factor's got to be between 1 and 10, remember, not over 10. So it's going to be 2.68. times 10. Now, it's a really small number, so I know my exponent's going to be 0. I go 1, 2, 3, 4, 5, 6. Maybe double check that. 1, 2, 3, 4, 5, 6. So negative 6. Let's try another one. Again, I want my decimal point here. 4.5 to the power of 10 with a negative exponent. 1, 2, 3, 4, 5, 6. Again, it's going to be negative 6. So try these 6 on your own. With top 3 are positive exponents because they're bigger numbers. Bottom 3 are negative because they're smaller numbers. And then come back and see how you did. So I have 5 times 10 to the power of 1, 2, 3, 4. 2.5 to the power of 1, 2, 3, 4, 5, 6, 7 times 10 to the power of 7. This one's going to be 6.83 times 10 to the power of 1, 2. Okay, now let's do the negative exponents. So it's going to be 5 times 10 to the power of 1, 2, 3, negative 3. Here's where I want it. So 3.3 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. So negative 7. Here's where I want it. 5.06 times 10 to the power of negative something. 1, 2, 3, 4. Negative 4. So finally, you have your homework there at the end of the lesson. 9.5, numbers 6 through 31. And then 9.6, you're going to do problems 3 through 22. You should do this on paper. And the only reason I ask you to do it on paper is some of your answers are going to get really big, really small, and you don't have a lot of space to do it on your iPad. So I would recommend doing it on your paper. If you have questions, please let me know. Otherwise, good luck.